Right, hello everyone. My name is Vic van Gool, and I'm the CTO of Cloud66. My co-founder Cash was actually meant to be doing this talk, and this isn't usually my thing, so be gentle with me, please. I'm here to talk about building multi-cloud, high-availability web application with Docker. So a little bit about Cloud66, what we do. We're a full-stack hosted container management as a service. You heard Fuchsmaus here first. It's going to be a thing soon. A little bit about us. We manage 2,100 applications over more than 3,000 servers, 8,000 developers in 800 companies, over 8 cloud providers, 79 data centers. So why plan for high availability? One of the problems is that the cloud is fantastic. It's really easy, it's good, but it's not infallible. We've had experience across many cloud providers, obviously, saying nothing about the Rackspace guys here. And stuff happens to servers. You have hardware failures, you have disk drives blow, network cards go. You have all sorts of issues that happen. There's in fact an interesting Google Cloud tech demo that they did with a live migration where they had a server which had a hardware failure, and they live migrated it to another server. Everything was still going well, but the reality is that not everyone across the whole range of cloud providers has those services currently available. But even if that is all sorted, there's still the macro stuff you have to worry about. What happens when you have a power outage in the region? The whole region is down. You have some UPS power failures. You have act of God. You have an earthquake. You have a drought's probably okay. You have a flood. And in those cases, think back to, I think it was probably about 2013 when Amazon had an outage in US East 1, which is their primary region at the time. Everyone who knows about Heroku everyone who was on Heroku was down at the time as well. So you have the macro stuff that you have to worry about. So here's a customer of ours, actually. They're called SafeCast. And what you're looking at there is a Google map image of Fukushima in Japan, on the east coast of Japan. Back in 2011, there was a Richter 9 earthquake out in the Pacific that caused a tsunami that came inland and caused a nuclear meltdown. And this is actually a map of the radiation that's remaining in the area. So SafeCast had a novel approach to measuring this radiation. What they actually did was they took a quadcopter, they stuck a Geiger counter on top of it and stuck a mobile phone on top of that, and they flew that around these radiation sites. Then they had a real-time data API, which they were sending all this data back to, and they had a requirement that they wanted to have a local data center because they needed low latency for their application. The problem is that for them, local data centers is inherently volatile because, they're looking at disaster sites specifically. So they wanted some kind of failover solution. And their goal was 5-minute switchover window. They didn't want anything more than that, and they were happy to have a 5-minute switchover. So is this relevant? Does everyone actually need this? You could say, okay, well, a lot of people right now have applications 80% of the time. They don't really need a real-time failover. But most people you'll find will be very happy with a 5-minute failover. If you look at if the comparison of being, hours, days, weeks in some cases. So the best way is to make it easy, make it cheap for them to have a failover. And now's a good time because cloud computing is really accessible to everyone. It is cheap. It is accessible. Right, now I'm going to do something dangerous, which is a live demo, which I only worked on this afternoon. So. Okay. Right, so what you're looking at here is, this is Cloud 66 dashboard. I've got two stacks. A stack in common language really is just a bunch of servers in a particular region forming an application. So they're the same application. One of them's running in, I believe, DigitalOcean, New York. One of them's running in DigitalOcean, Amsterdam. Right, so they're physically located halfway across the world from each other. And what I've done is I've created a master stack and a slave stack. And just to be clear, that this doesn't have to happen to Cloud 66. This is absolutely applicable to anyone building their own stacks using whatever technologies they want to use. And this is just a concept. So what I've got here is a slave server, which is running, they're both running MySQL in this case. They could be running in a database. And I've configured the slave server to be a replication slave, actually, of the master. And what I can do now is essentially just go to that. Imagine there's a catastrophic event and the master stack is inaccessible at this moment. So maybe you can still hit the web server, it's not working. Maybe you can't hit the web server, I don't know. So in this case, I'm going to go to this application. I'm going to change the default holding page to essentially be, if I can click, I'm going to create a redirect rule, essentially in Nginx. I'm going to put the stack in maintenance mode. So this means now if I go and hit the stack, I'm going to see a holding page, essentially. This is our master stack. I have what is called a failover group. This is, again, Cloud 66 language, but it applies to everything. A failover group is simply a DNS rule which allows us to configure where the endpoint is pointing at. So you have an external DNS pointing at your local DNS, and your local DNS pointing at the head of whichever stack it is you're talking about. So in this case, it's pointing at master. I had it actually loaded here before I switch over to maintenance mode. So this is this is what I just actually ran now. So you can see that from externally hitting the failover group, we're looking at the server 6FD, and it's at 80 hits. I then going to go to my slave, and I'll disable replication. And now I've chosen to have master-slave replication specifically because I don't want anyone to access my slave. I don't want any kind of data happening or being added to my slave at this point. I only want replication data coming across. So I've gone to my slave, and I can actually disable replication here, just with a couple of clicks. Configure replication, and let's disable it. There we go. So that'll just take a few minutes just to, well, not a few minutes, but a few seconds just to disable replication, bounce the database, etc. And this is, all this time, any traffic still going to the original site is getting the holding page, essentially. So if I look here, so it's just disabling. This is when I wish I knew some jokes. And it's still disabling. While that's going, actually, I'm just going to flip back to this quickly and talk about this reality. I love this slide, actually, because it's exactly, I think, what DevOps is. It's like we do a whole lot of really nasty stuff behind the scenes. And, everyone sees the fantastic front end, but, the stuff on the left is what it's all about, right? All right, let me come back to this. All right, so replication is finished. I'm now going to go to my failover group, and I'm quickly going to switch stacks to the slave stack. Do I want to switch traffic? Yes, I want to switch traffic. Failover group is updated. Right, now I'll leave that. This is DNS. I come back here. Okay, so breaking down basically what's just happened is the main parts of your application that you need to fail over in this situation. You've got the app data itself, or the application itself. So one of the problems with using scripts, and I know there are a lot of keen scripters out there, but one of the problems with scripts is that they go out of date quickly, and they're a hard maintenance overhead. You have to keep maintaining them. You have to keep somebody looking at them, keeping them up to date, because the starting point changes. what happens is you have a script and then you go and change something behind, that in the early days of that script, you try and run the script again from the start and it doesn't work. So you have to keep them up to date. And Docker's great because Docker solves a lot of that problem. Docker allows you to build your application in an immutable way such that it can be deployed across different hosts, and you know that it's the same application. You know that the build of that particular container is what you desired it to be. So you have private registries for Docker as well, which allows you to have your application in a safe place. You can define it wherever you want. Your private registry can be located anywhere you want. You can create it yourself. Then you have the data components. So we talked about replication there. So database replication is important. But a lot of people make a mistake that what they do is they set up replication, and they're like, right, it's going, it's working. One of the problems is that the worst time to figure out that your replication has a problem is when you need to fail over to that server, the replication slave. So you really do need to have monitoring. You need monitoring there to tell you that data is still flowing to your replication slave, that everything is still okay there. And replication we use because the reality is that when you have large databases, we're talking like many gigabytes, hundreds of gigabytes of data, what ends up happening is that the physical time to actually move that data to another server is a bottleneck. It takes a long time to move a lot of data. So it's better to think about this stuff in advance, set up replication, pay that overhead when it's not a problem for you, and then let replication just keep you up to date. Thank you. So then networking is the last bit. So you can set up an integrated switching solution where you have many HA proxy servers configured around the globe that are providing a network of complete safety, fail-safe loops from back and forth, and they get configured by themselves or based on traffic. The problem is that it's actually quite hard to maintain that and can get expensive to do that. And the reality is that most people don't need that instant failover. So we use DNS for that failover of traffic. So DNS is great. You have as Charlie mentioned, so you can set it with a TTL of 5 minutes. And that means that the majority of cases, people will be switched over within 5 minutes. There's obviously going to be some old routers out there that don't obey the TTL rules, but I think that's a very small use case. And we use Route 53 for our DNS updates. It's great. It's a nice API, and it allows us to do everything that we want to do. We can create routes, we can delete them very easily. Okay, so one of the, this is kind of more anecdotal, I guess, but we've been in situations where we've had customers and they've had a failover event happen. And what typically happens, and it's for everyone, right? Whether it's your customer, whether it's your boss, somebody is shouting at you at the time that this happens. And you really, really have to make sure that your failover processes are solid. You've been testing them. They are good. You've built test stacks. You've gone through this whole process end to end multiple times. The very worst thing that you can be doing in this situation is SSHing into the server to try and debug why it's not working, which has been known to happen. All right, so I don't know if that's been long enough, but let's go and have a look. So here we have just the failover group endpoint. So if I refresh this page, right, I've got a new server, I've got a new application, everything's running. We're now on the slave stack. We're all good. At this point, we can now go and diagnose what's going on with production. That whole process really takes up to 5 minutes. It really shouldn't take longer than that. So there's another thing just to mention here, and this is an experience that I've had as well when talking about failover. So, as I was saying, you often have somebody to report to. You have somebody who is breathing down your neck during this time, and it's really important to articulate to them what is involved in a failover process, because it's very easy for somebody to not understand magic and think that therefore magic is just magic. And let me explain that. My mum, I recently showed my mum a Google Translate app, and it's really cool. You type in some English text, hidden button, and it comes out in French. And it speaks back to you in French as well. And my mum saw that and she's like, wow, that's amazing. That's awesome. And so I can have a conversation with it now, right? And I thought, well, how can you think you can have a conversation with it? Don't you understand that there's two different things going on here? And what essentially it is that she didn't understand the first part, so she doesn't understand the second part. They must be equal. They're equally difficult. And this is the case for failover. There's a lot going on, and you need to make sure that people understand that there's laws in place. Right. So I think it's obligatory to say we're hiring. We are hiring. So if you're interested, if if you're exceptional, then come give us a shout and talk to me or ping me, and be happy to talk. And thank you very much, everyone.